We're now going to introduce the inverse trigonometric functions. The first one that we're going to talk about is the inverse sine function. Let's introduce some preliminary information first, though. What I have drawn here is the graph of y equals sine of x. You should notice right off the bat that the graph of y equals sine of x is not a one-to-one function. The reason it's not a one-to-one function is because the horizontal line crosses the graph in more than one spot. Therefore, the function y equals sine of x will not have an inverse function. However, if we restrict the domain of y equals sine of x to include only values of x between negative pi over 2 and pi over 2 inclusive, we then have a one-to-one function. So that gives us the following definition. The inverse sine of x. Y equals the inverse sine of x, or the arc sine of x, means x equals the sine of y, where x is going to be a quantity between negative 1 and 1, and y is going to be an angle between negative pi over 2 and pi over 2. Both values are inclusive. One of the characteristics of the inverse functions is that if you take f inverse of f of x, you get x back. Therefore, the arc sine, or the inverse sine of the sine of x, is going to give you x, where x is in the domain of the sine function. Because x must be in the domain of the sine function, the value of x must be between negative pi over 2 and pi over 2 inclusive. In other words, within our restricted domain. In addition, f of f inverse of x gives you x, where x is in the domain of f inverse. Therefore, the sine of the arc sine of x is going to equal x, where x must be a number between negative 1 and 1 inclusive. So here we have the characteristics of y equals the arc sine of x. The domain of y equals the arc sine of x is the same as the range of y equals sine of x, that is between negative 1 and 1 inclusive. Remember, the domain of an inverse function is the range of the function f. In addition, the range of y equals the arc sine of x is the domain of y equals sine of x. The domain of y equals sine of x, you recall, is the values between negative pi over 2 and pi over 2 inclusive, because we had to restrict the values to make the function one-to-one. If we look at the graph of y equals sine of x and y equals arc sine of x, we notice that it has all the key characteristics of a function and its inverse. That is, the graph of y equals arc sine of x is the graph of y equals sine of x reflected about the about the line y equals x. So now that we have all this preliminary information, let's go ahead and evaluate some inverse sine functions. For example, suppose we wanted to evaluate the arc sine, or the inverse sine of 1. Here's what that means. It means that there's some angle theta whose inverse, there's some angle theta that equals the inverse sine of 1. Another way of thinking about this is the sine of some angle must equal 1. However, the angle must be between pi over 2, negative pi over 2, and pi over 2 inclusive. Can you think of an angle whose sine is equal to 1 and the angles between negative pi over 2 and pi over 2? You should immediately think that theta is equal to pi over 2. What that means, therefore, is that the inverse sine of 1 is equal to pi over 2.